Hi guys, today we're going to be discussing derivation of radicals and oxidation numbers. Now we've been on this series for quite some time, and in the previous association we discussed how we can get radicals using oxidation number and how we can also get oxidation number using radicals. Now we did a couple of very simple calculations in the previous association. So today we're going to be going into deeper calculations on this. So if you look at this right here, I have an iron, this a complex ion, NO3 trioxynitrate 5. So I don't know if this is going to be a positive ion or a negative ion. But with the knowledge of oxidation number, we could get the kind of ion that this is. We could get to know if this is going to be positively charged or negatively charged. So the first we have is nitrogen. Now nitrogen has an atomic number of 7. Nitrogen has an atomic number of 7, while oxygen has an atomic number of 8. So what we're going to do first is we're going to be getting the radical. Don't forget the first 20 elements, we said according to electronic configuration in the previous association, we're talking about for the first 20 elements, we use the 288 shell filling. So the first shell takes 2, the second one takes 8, the third one takes 8. So for nitrogen, which is atomic number 7, that means it's going to be 2 first for the first shell. After 2, what we have left is 5 for the next shell. So this is not going to be complete. This is not up to 8. It's not up to 8, so we need 3 to balance this. So for the fact that we need 3, that means nitrogen has to bring in 3 electrons or gives away 5 electrons in the second shell to make it balance. So the oxidation number for nitrogen is going to bring in 3, which is minus 3, or give out 5, which is plus 5. That's that for nitrogen. So for oxygen, let us get the configuration, electronic configuration. Oxygen is 2 first for the first shell. After 2, the next we have is 6. That's complete. So as you can see, the oxygen also is not complete. Oxygen needs 2 electrons to become balanced. So it will either take in 2, that is borrow 2, or gives away the 6 electron in the second shell to attain balance. So oxidation number for oxygen will be either minus 2 or plus 6. So now if you look at this NO3 trioxynitrate, that's 3 oxygen and 1 nitrogen, trioxynitrate 5. This is a trioxynitrate 5 ion. I don't know if it's positively charged or negatively charged. So we're going to get to know now once we're done with this. So the next thing you're going to do now when you look at the nitrogen has 1 atom. So you're advised that the first atom of element should be positive. That is the first atom of this element. You're advised to take the positive oxidation number, that's plus 5, and the second one could be negative, that is minus 2. So if you look at it, nitrogen has 1 atom, so that is 1. Oxygen has 3 atoms. So there's 3 atoms of oxygen and 1 atom of nitrogen. So that's going to be 1 times. So the first one we're going to go with the positive oxidation number, 1 times plus 5. Then plus the second one, which is oxygen, we're going to go with the negative now. So you can't go with negative or positive. One has to be positive, the other one has to be negative. So oxygen here is 3 atoms, 3 times. So oxygen is minus 2. So what do we have? That's 1 times plus 5 is plus 5. Then plus 3 times minus 2 is minus 6. This is basic arithmetic, very important you have your knowledge of that. So plus 5 plus is minus. So plus 5 minus 6 will give us minus 1. So it means NO3 is 1 minus. It means NO3 is an anion. That's what it means. So here's another example. SO4 tetroxysulfate 6 ion. So we don't know if this is going to be a cation, that is a positively charged ion, or a negatively charged ion, which is an anion. Now we are going to be doing this also. We're going to be using the same approach we used in the very first one. This SO4. So how do we get to know if this is going to be positively charged or negatively charged? So you're only going to get to know by using their oxidation number. Don't forget that we could use our oxidation number to get the radicals for different kind of ion, different kind of compounds. So when you look at this SO4, so first of all, the first thing you're going to get is you're going to be getting the oxidation number for each of this element. Here we have sulfur and we have oxygen. 1 atom of sulfur and 4 atoms of oxygen. So first of all, oxidation number for sulfur. Now, how do we get that? Let's get atomic number for sulfur first. Sulfur is number 16. That's sulfur on the periodic table. Sulfur is the 16th element. So what's the electronic configuration for that? Sulfur, the first share will take 2, second share will take 8. So the third share should take 8 also, but 2, 8, that is 10. We have 6 left. So this 2, 8, 6. So first share 2, second share 8, 10. The last shell is 6. So what does that mean? It means sulfur, oxidation number for sulfur now. It means sulfur needs 2 here for the third shell to become balanced. So sulfur is going to either borrow 2 or gives out the 6 to attain balance. So sulfur is going to be plus 6 or minus 2. That's the oxidation number for sulfur. Now for oxygen. Oxygen is well known. Atomic number for oxygen, as stated up there, is 8. So if oxygen is 8 based on the atomic number, it means the electronic configuration. So the first shell takes 2, second shell should be 8, but second shell is going to be 6 because of you're talking about oxygen. Yes, so it's complete 2, 6. That's 8 electrons altogether. So that means oxygen will need 2 electrons to become balanced, or it gives out the 6 also. So oxidation number for oxygen is going to be either plus 6 or minus 2 also. The same thing with sulfur. So what do we do next? Now the next thing we're going to do is sulfur has 1 atom, oxygen has 4 atoms. So sulfur, the first is 1 atom 1 times. Now don't forget, as we advised in the very first example, the first one should be positive oxidation number, the second one should be negative oxidation number. So 1 times plus 6, then plus 4 atoms 4 times, second one, that is minus 2 for oxygen, 4 times minus 2. So 1 times plus 6 will give you plus 6, then plus 4 times minus 2 will give you minus 8. So what's that? That is plus 6, plus and minus is minus, plus 6 minus 8, that will give us minus 2. So it means tetraoxosulfate 6 ion is also another anion, a negatively charged ion. So SO4 is 2 minus. So that is that. So this is a final example on how to get radicals using oxidation numbers. So there's a final example. So NH4, this is ammonium. So we don't know if this is going to be a positively charged ion or a negatively charged ion. So, but with the help of the oxidation numbers, we could get to know what it's going to be. So first of all, we have our nitrogen and our hydrogen here. So we're going to be getting their oxidation numbers first. The same approach we used for the first 2 questions. So first of all, nitrogen, atomic number for nitrogen has been set up there. Nitrogen is 7. So nitrogen is 7. So oxidation number for nitrogen, what is going to be? Don't forget, nitrogen is 7. That is 2, 5. So oxidation number for nitrogen is plus 5 or minus 3. That's that. That is known already, well known. We've done that already. So next, hydrogen. That's hydrogen. Atomic number for hydrogen is 1. So hydrogen is protose, the first major element among all the elements. So oxidation number for hydrogen naturally is plus 1 because it's the first element. So don't forget here, we need 1 positive, 1 negative. Now for the fact that hydrogen is positive, that's positive oxidation number, it means the nitrogen should also be negative. Nitrogen cannot be positive. You can't have positive. So one has to be positive, the other one has to be negative. So we're going to be going with the negative oxidation number for the nitrogen and the positive oxidation number for the hydrogen. So nitrogen has 1 atom only, while hydrogen has 4 atoms. So that's going to be 1 times the nitrogen minus 3, then plus hydrogen down, 1 times, what do we have here? That's 4 atoms, 4 times 1. So 1 times minus 3, that will give us minus 3 plus 4 times 1, 4. So minus 3 plus 4 will give us plus 1. So it means ammonium is a positively charged ion. That's a cation. This is a cation, positively charged. So just our plus. So that's that for the radicals. Okay, now here's the first question on how we could get our oxidation numbers or how we could get our valency from a given known ion. Now, as you can see, this ion is already known. This is a negatively charged ion. This is an anion. As you can see, this CO3 triisocarbonate 4 ion. So this negatively charged, this has a -2 radical on it. So now, as you can see, this carbon was underlined. Now we are asked to get the oxidation number for carbon. Now don't forget the fact that oxidation numbers will combine together to bring about these radicals. So what's the oxidation number for carbon? And don't forget that once you get your oxidation number, it's as good as getting your valency. Now this is a charged ion, this is an ion, this is a radical. So how do we get the charge for carbon? The oxidation number, I beg your pardon, for carbon. Now it's very simple. Now the first thing you're going to ask yourself is this: how many atoms of carbon do we have? Carbon, we have just one atom of carbon, and we have 3 atoms of oxygen. Now we are asked to get the oxidation number for carbon. So how do we do that? So carbon has 1 atom. That's going to be 1 times carbon itself, then plus. And don't forget the oxidation number for oxygen is -2. It's very basic. That's the basic oxidation number for oxygen. So oxidation number for oxygen is -2. So that's going to be 3 atoms of oxygen times -2. Now when you combine all this together, you end up having -2 right here. So 1 times C, which is the carbon, the C, plus 3 times -2 is -6 equals to -2 right here. So we're going to send this, so C, plus and minus is minus, equals to -2. This C minus C is equal to -2. So collect your like terms, send this to the other side. So carbon is +6 minus 2, so carbon is +4. So the oxidation number for carbon is +4, or we can say the valency is 4. For valency doesn't have any business with if it is positive or not. So that's that for that. That's the first example. Okay, now here's another example. Now this is potassium heptaoxo dichromate 6. So we are asked to get the oxidation number for this very chromium, that's a Cr2. So as you can see, this is not a charged radical. This is a neutral radical. There's no charge at all on this. So the first thing we're going to do is we're going to be using the oxidation number. Now oxidation number for potassium. Potassium has atomic number of 19. So potassium has oxidation number of 1, while oxygen has oxidation number of -2. So we have 2 atoms of potassium and 7 atoms of oxygen. So that's going to be 2 times potassium, which is 1. Now plus the chromium we are talking about is 2 atoms of chromium, which is 2 chromium like this. Then plus oxygen, which is 7 atoms, 7 times -2. By the time you combine all of them, you end up having 0. So 2 times 1 is 2, plus 2 chromium right here. Then plus 7 times this is -14, equal to 0. So you're going to collect our like terms now. This is 2 plus 2 chromium minus 14 equal to 0. So 2 minus 14 plus 2 chromium equal to 0. 2 minus 14 is -12 plus 2 chromium equal to 0. So collect your like terms. You send the -12 to the other side. So there's 2 chromium equals to 12. Divide both side by 2. So chromium is 6. So the oxidation number for chromium is 6, or we could call it the valency of chromium is 6. So, a couple of take-homes. So as you can see, the first one, these are the radicals. So the first thing you're going to do for me is you will get the radicals for this very ion, PO4, tetraoxophosphate. So just give me the radical. So MnO4, give me the radical for that. And now the oxidation number, we have copper hydroxide, CuOH2. You have lead nitrate. You have H3PO4. So you get me the oxidation numbers for all these underlined ones. This very one here. This very one here, the hydroxyl is being underlined. So get me the oxidation number for this, for nitrogen, then for this very phosphorus. So at this very point in time, we're going to be drawing the curtain on today's exposition. So if you have found this exposition very resourceful, please subscribe to this very channel and share this exposition. See you in the next exposition. Thanks.